Good morning, everyone. I wasn't thinking while I was setting up and my computer was having internet issues, and when I went to reboot it, it was like, oh yeah, updates. I'm like, yeah, sure, whatever, I have time. I was like, ooh, that was a bad plan. But it did update and now it's back, so we're only just a minute late, so. So the goal for today is to finish off the section of this chapter that talks about our classical conditioning. So we should be able to get through all of it today, and then that'll leave us the operant conditioning and social learning for next week. So first off, we're going to start by talking about a term called preparedness. And this kind of goes along with that idea that I talked about sort of at the end of last week's, Wednesday's class, where we were talking about that acquired food aversion, where you learn to avoid a food if it makes you sick, and how we have that sort of biological predisposition to avoid foods that make us sick. We also have biological predispositions to learn other types of associations. And so there's this nice, very elegant experiment that had looked at this in rats. And so the chart that's here is actually our results, but I'm going to describe the setup to you. And so this setup was done where rats were presented. So rats were presented with water that had a bunch of things going on with it. So behind the water, there was light, there was sound being produced, and then the water had also been sweetened. So we could call this bright, noisy, and tasty water. So there were two groups of rats. Some of them would drink from this water, and afterwards they would receive a shock. I don't remember the specifics. Usually when it's rats, they would have a mild current on the bottom of the cage, so it would cause sort of a physical sensation. The other group, after drinking from the water bottle, would be exposed to X-rays, specifically so that they'd have exposure to radiation, with the idea that it would then produce nausea and then they would throw up. And so what we wanted to learn was which part of that water, which weird aspect of the water did they associate with what bad thing had happened? So was it the fact that it was bright light? Was it the sound? Or was it the taste that they associated with whatever happened to them? And it depends on the type of stimulus that they received. So our unconditioned stimulus here for the shock group, they associated the shock with the bright light and the sound. So we can see here, if we look at the difference, so the rats would have been offered an option between a bright and noisy water bottle, meaning that they had a speaker playing the same sounds and it had a bright light behind it, or they could choose to drink from a water bottle that just had sweetened water in it. And so they would choose to go to the sweet water more often than the bright, noisy water. So they were associating that physical pain with something sort of visual and auditory. So they were associating those kinds of cues with something that caused them physical pain. And then if we look at the X-ray group, when given that same choice, do you go to the bright, noisy water or do you go to the tasty water? They avoided the tasty water. So they chose to go to the water that had bright light and sound, and they avoided the one that tasted funny. So they associated something that made them sick with something they could taste, and they associated something that had hurt them with something that they could see and hear. So this shows that we have this preparedness, sort of a biological predisposition to learn specific types of associations. And that kind of makes sense. Like if something makes us sick, it's probably something that we ate. That's a good, fair assumption. That's why we get those food aversions fairly quickly. And if something is going to cause us pain, we might associate it with, say, predators or dangers in our environment. And we would identify those dangers by watching for them and listening for them. So it makes sense that those would be associated. And so there's lots of really neat experiments like this where you can find different things that we are prepared to learn and that we tend to learn a little bit more easily. So I thought that would be neat to point out. Okay, so next we're going to talk about the process of extinction. So this is when we've learned an association, we've gone through that acquisition phase, what happens next? So extinction is a process where we have our conditioned stimulus and we present it without our unconditioned stimulus. So if we go back to that example of ringing a bell and giving a dog food, once they've learned that association, just ringing the bell will make the dog salivate. They'll produce a conditioned response to their conditioned stimulus of a bell. But if we ring the bell and don't give them food over and over and over again, they learn that the bell used to mean food, but it doesn't anymore. And so we should see that the dogs drool less and less as that association weakens. So our conditioned response, the dogs drooling when they hear the bell, will get less and less intense and eventually disappear. And so what this looks like graphically would be something kind of like this. So this is a pretty standard graph. We have time along the bottom, and then our y-axis is what we care about. That's the strength of our conditioned response. So that's just saying how much responding are they doing. So low for our salivation example would be the dogs aren't drooling, and high would be that they're producing a lot of saliva. And we can look at this for, say, startle responses or whatever kind of response we have. So it's just sort of a magnitude thing. And then the graph will always look about the same. So the first part is our acquisition. So we have our conditioned stimulus and the unconditioned stimulus presented together. So we get that nice acquisition curve all the way up to the top. So eventually the dog learns that when you ring the bell, it's associated with food, so they will salivate. So we see very high responding at the end of that acquisition period. Then we have a little bit of a break, so that little white line means that we've transitioned to our extinction phase, labeled up at the top again. And now there's no unconditioned stimulus. Now there's no food. You're just going to ring the bell, and ring the bell, and ring the bell. And so at first, right after you've trained the dog that the bell comes with food, they're going to still be salivating because they still expect the food. But over time, when they hear the bell but don't get food, they're going to stop salivating because we've weakened that association. So we see that drop off in responding. So our strength of our conditioned response will get smaller and smaller, and eventually we'll have no response at all. So that's the process of extinction. After extinction, we occasionally see a strange phenomenon called spontaneous recovery. And this happens when a seemingly extinct conditioned response reappears if our conditioned stimulus is presented again after a delay, after we've gone through extinction. And it's usually going to show up in a somewhat weakened form. And so the words might not mean anything, but if we go back to our diagram here, we have that blue stripe that says pause. So maybe you go home for the day. You've been ringing your bell at the dog all day, you go to sleep, and then the next morning you ring the bell again. So there's been a bit of a break, and you come back, and we see that there's a little bit of responding. It's not the same as right after the acquisition phase, but we do see some salivation. So a weaker conditioned response is occurring. And we can then have that go through the extinction process alone. If you keep ringing the bell and they still don't get food, that's going to drop off even more. If you had another pause and did it again, it would probably start at about half that amount a second time. And you could keep repeating this until you saw less spontaneous recovery. But each time that we see that sort of reoccurrence or resurgence of that behavior, we would call it spontaneous recovery. So this is when maybe you've had a fear of something and you got over your fear, but one day it kind of sneaks up on you and you have a little bit of a startle, and it's because you are spontaneously recovering what you had learned previously. And the idea here, this is, I believe, a little bit beyond what you need for the course. It's because that acquisition process, extinction isn't unlearning the acquisition process. You're actually learning something new that ends up competing with what you had learned during acquisition. So it's not like you're undoing that learning process, you're just learning something else. And so sometimes you'll default to what you had learned first. That's just what's going on there. So if you take sort of higher level learning courses, they talk a lot more about sort of competing learned associations, and that's what goes on here, is something a little more complicated in the background. But the next thing I wanted to mention are sort of another sort of special case here. And these are our safety signals, or our conditioned inhibitors. And so this is an idea where you can have signals that tell you that a unconditioned stimulus is going to occur, or that it is not going to occur. So it kind of makes sense. We've been looking at just what we would now call a conditioned exciter, which is a normal conditioned stimulus that ends up producing a conditioned response. So if we have our diagram as an example, so we would present an animal or a person or whatever with these two shapes. So there's a rectangle and a star. And when they're exposed to the square, I guess, and the star, there would be a puff of air. So that unconditioned stimulus is a puff of air, and it produces a startle response. Eventually, just seeing those two shapes would produce its own startle response. So we'd get a conditioned response to the presence of our square and star. But if we are then exposed to something slightly different, so on the bottom, we still have the star present, but now it's presented with a triangle. So the triangle is what we would call a safety signal, or a conditioned inhibitor. And so this is a new kind of stimulus that lets us know that that unconditioned stimulus is not coming. So it's telling us that the puff of air is not going to happen. So it's letting us learn a new thing. So when the square is there with the star, we would startle. But if we have the triangle instead, there's no need to jump because we know that we're safe. So we have been signaled that it is a safe time, and we don't have to have a reaction. And again, in the background, there's a sort of additional learning processes going on. So these conditioned inhibitors are basically giving us an alternative situation where we know that thing that we have acquired no longer applies. So we've learned that that's a safe symbol, and we don't have to respond when it happens. All right. So next I want to talk about two very closely related concepts, and these are stimulus generalization and stimulus discrimination. And hopefully I'll be able to sort of explain it in such a way that we can tell the difference between the two, because this is one of those questions that you are absolutely going to see in testing. But stimulus generalization is basically the process where once you've established a conditioned stimulus, once you can get it to produce that conditioned response reliably, we find that similar stimuli may also lead you to produce that conditioned response. So if you ring a bell and your dog salivates, what happens if you have a smaller bell that makes a higher pitched sound? Are they still going to salivate? And so if they do salivate to that different bell that sounds kind of the same, then we would say that the dog has generalized because they're showing a conditioned response to something other than the stimulus they were originally trained on. So that's kind of a weird concept to wrap your head around. So I have a diagram that kind of helps illustrate this. And so this, I don't remember specifically where it's coming from, but I believe, just looking at lines, that tells me it's either a rat or a pigeon in a box, and they would peck in response to seeing a particular stimulus. This is just a standard thing you see in learning behavior. So the pigeons would be trained that if they see a vertical line and they peck a key, they would get food. So they would want to peck that key as much as they can when they see a vertical line. If they're only used to seeing vertical lines, then when we show them, say, a slightly diagonal line, would they peck to that too? Is it close enough to that vertical line or not? And if we look at this graph here, we would say that, yeah, we do see some responding to that horizontal line, to the diagonal line as well. So we see sort of a gradual curve there. And so if we look at what our axis is, it's actually just the strength of that conditioned response. So again, how much are they responding? With the dogs, it would be how much are they salivating. With this one, with the birds, it's how much are they pecking. But you see most responding to the thing that they have experience with, the thing that they've learned about. But We also see some responding to things that are similar. So that's the idea of generalization, where you would treat something that's kind of the same and react to it in the same way. But if we wanted to talk about being able to tell the difference between different stimuli, then we would be talking about stimulus discrimination. And so this is when we exhibit a less pronounced conditioned response to any new stimuli that differ from what we were trained on originally. So we're going to see a conditioned response to one stimulus, the one that we were originally trained on, and then we should see less of a conditioned response to anything else. So we have the same basic setup here, the same thing where we're looking at the strength of that conditioned response, but here we're seeing that they're responding a lot to the thing that they were trained on. They're responding a lot to the line that they were trained to respond to. And then we see very little responding to the other orientations. So in this case, instead of seeing that generalization, we're seeing that they're responding to the thing they were trained on and they're ignoring everything else. So if we were looking at salivation with our dog, if you ring the bell and they salivate, and then you get a new bell and it makes a deeper sound and they ignore it, there's no salivation, then we could say that they've discriminated between those two types of bells. We could even say that they can tell the difference between the bell that they were trained on and the new one that you tested them with. And that's going to be one of the really important concepts when I start talking about operant conditioning and how I look at how chickadees form sort of categories, because this lets us know, can they tell the difference between things? So if they can discriminate between two different stimuli, then we know that they can tell the difference because they react differently to them. So it's kind of a useful shortcut, especially when you're doing animal research. Okay, so our next topic is to go into, sorry, did you have a question?
Yeah, and can you apply all these things only to animals, or it can also apply to humans also?
Humans as well, yeah. Yeah, so this can apply to any organism, really. So if you, instead of wanting to look at dogs salivating or pigeons pecking, you could look at, say you have a person sitting in front of a screen, and when they see a blue circle, that you're going to blow a puff of air in their eye. So every time they see a blue circle, they're going to flinch, expecting air. If you then show them a blue oval, do they still flinch? If they do flinch, they generalized and they reacted to the oval the same way they would the circle. If they don't flinch, then we can say that they've discriminated between the two because they're treating them differently. Yeah, so we can do it for any kind of organism. It's just I'm more familiar with it in non-human animals. All right, so I had kind of hinted at the fact that higher order conditioning was a thing that we could be talking about. So this is where we're going to be able to give a little bit of a review of our terms again of normal I guess, unordered conditioning, just plain old classical conditioning. And then we're going to look at what happens when we add steps to it. What happens with this higher order conditioning? And so our definition is that this is a conditioning procedure where an already conditioned stimulus is paired with a neutral stimulus. So if we had our dog where you ring the bell and they salivate, you would then use that bell in order to train another new stimulus, another neutral stimulus. So I'm going to give us an example because it's a kind of a weird concept to think about. But we can get a second neutral stimulus to eventually become a second conditioned stimulus, which will then elicit a conditioned response, even if you've never paired it with an unconditioned stimulus, which is pretty cool. So this was the diagram that we had looked at with just normal plain old conditioning. So we started at the beginning, we have our tone instead of a bell, we're still giving the dog food. So before they learn anything, they don't react to the sound, there's no responding to it. When we give them the unconditioned stimulus, when we give them the food, they salivate. So it's an unconditioned response. Then during conditioning, during the acquisition phase, we pair them together, so we get the conditioned stimulus and the unconditioned stimulus together, and we're going to get an unconditioned response. So they're going to be salivating because you're giving them food while they're also hearing that tone. And then afterwards, once they've learned that association, if you have the tone by itself, you're going to get a conditioned response. The dog will salivate just to the tone, even if there's no food present. So we can then say that our tone is now a conditioned stimulus. So that's normal classical conditioning, but this is also step one of our higher order conditioning. Step one is setting up that first conditioned stimulus. Then we introduce a second step. So for this part here, we'd have our second neutral stimulus. So now we're going to have a black square. So we're using something different than an auditory cue now. And so if you show a dog a black square, it doesn't mean anything. So it's a pretty good neutral stimulus. It doesn't elicit a response. During our higher order conditioning, we're going to take that black square and present it at the same time that the dog hears the tone. So we're now calling that tone our conditioned stimulus, and it's denoted with a number 1 because we are going to have more than one conditioned stimulus. So we just say that it's the first conditioned stimulus. And you'll notice that we're not involving food at all here. We're saying that the dog has already learned something about that tone, and now we want the dog to associate the square with the tone to almost piggyback along with what it had learned about the tone. And so when we have that paired together, we're going to get that salivatory conditioned response because they're still salivating because of that first conditioned stimulus. So we're still calling it a conditioned response because the source is not an unconditioned stimulus. So that's fine. But then when we get to the bottom, we present the black square on its own. And if the black square alone can elicit a conditioned response, if that black square alone makes the dog salivate, then we can call that a conditioned stimulus too. So that is our second conditioned stimulus. And so the idea here is that most things that we encounter, most ways that we experience classical conditioning is actually through this higher order conditioning. Because it's very rare for us to have things sort of directly paired with something that produces a physical response. We make a lot of associations between things that we've already learned something about. So I usually use the example of advertising for higher order conditioning, and especially companies that advertise for alcohol. So if you have like a beer company, and so they want you to like their beer. And so they're going to put out advertisements of really attractive people at parties. And it's because you see pictures of attractive people at parties and you think, oh, I would like to be at a party. Parties make me feel good. That would be something good. So then when you see their alcohol with attractive people, you think, oh, well, attractive people at parties are good. So their alcohol, which is with those people at those parties, is also good. So you would get sort of the residual good feelings from learning that sequence of associations. So we get lots and lots of things that we can learn through this higher order conditioning. And again, for the purposes of testing, when I present something as higher order conditioning, we usually use the same kind of setup where we talk about something was established as a conditioned stimulus, or we'll describe it in sort of a very simplified way. I find, especially with those upper level learning classes, you can frame things in a bunch of different ways. I go with the very straightforward framing mechanisms to make sure no one's confused. But the text also has a couple of really good examples of sort of types of conditioning and then questions about which is the conditioned stimulus and the unconditioned stimulus and so on. Those are really good things to practice. Okay. All right, so that was our higher order conditioning and a sort of sneaky review of regular classical conditioning. So next we're going to be talking about, we're kind of moving over into things like fears and phobias and stuff like that. And so, of course, in psychology, if ever you talk about learned fears, we always mention the case study of little Albert. So if you haven't heard of this before, this is related to John B. Watson, who you might remember as our person credited with establishing behaviorism. So if you think of behaviorism, that was when we were focused only on our environmental influences. So John Watson said that, nothing internal matters. If I can have a whole bunch of children and I can control their environment entirely, I can turn them into whatever profession I choose. We can completely control absolutely everything about their behavior simply by controlling their environment. And so he was involved in some research with a child who was known as Little Albert. It's kind of the same way that nowadays with case studies, you'll only see them use letters. So HM is a case study, and it's intended to protect their identity. Usually once they've passed away, then you can sometimes figure out their full name, or if they consent to give their full name, you'll see the full name. But with Little Albert, there's kind of a bit of a mystery, but I'll get back to that. And so this was looking at training fears into a young child. So I believe he was about 9 months old when this started, so his mother brought him into the lab, and Watson was exposing him to a white rat. So this white rat would be a neutral stimulus. It doesn't mean anything to him. So a rat isn't innately scary. It didn't produce any kind of response. He saw a rat and it was fine. Then they conditioned a fear response to that rat. So whenever the rat was present, especially whenever Albert was touching the rat, they would ring a loud gong in the background. So it was a very loud, startling sound, and it would scare him and make him cry. And so every time he touched the rat, they would make the loud sound and he would cry. And eventually, touching the rat would make him cry, or even seeing the rat would make him cry. And then we got to the point where they started showing little Albert other things that might be white and furry. And they started noticing that he was generalizing his response to other things that were white and furry, like a fur coat. And so there were some things that he did generalize to, and then there were other things that he didn't have a fear response to. And I think they said specifically there was a Santa coat that he didn't respond to. So maybe something about the red made it okay for him to be around. But it shows us that there is a way to sort of condition these fear responses, and we can see them generalize. This is also one of those cases in early psychology that really led to us needing to have ethics. So at the time, they had the mother bring the child in, they trained these fears into him, and then he sort of disappeared. The mother stopped bringing him in, and they just moved elsewhere. And so there's a lot of debate on who little Albert is or was, and what happened to him, and whether he was ever sort of untrained to be afraid of rats and things that are white and fuzzy. So there's a bunch of different takes on it, a bunch of different stories, and I've seen many, many different interpretations. One of the most recent ones is that he was someone whose mom was a nurse at the local hospital and brought him in, and they never acquired the fear badly. He didn't like pets from then on, but it wasn't sort of bad in his life. It was just something that happened, and he lived a normal life otherwise. I've also heard versions of it where he moved away and lived a very short, painful life. There's a lot of sort of disagreement on who he actually was and what actually happened. So I guess protecting his name kind of went a little too far because now they're not sure who he was. But it's just one of those fun little mysteries that pops up every once in a while. All right, and the last thing that I wanted to talk about while we're on the topic of learning fears is the idea of phobias. So a phobia is an extreme and irrational fear that's directed towards people or objects or situations. So you might be agoraphobic. You might be afraid of sort of open spaces or crowds. You might be, I can't remember the one, or arachnophobic is for spiders. Coulrophobic is for clowns. There's a name for everything. So you can have these very extreme fears, and they're specified that they're irrational fears. So you're afraid of something that shouldn't be harmful to you. And so this is something that is pretty problematic in people's lives because fear responses can be very, very intense. So you can have anxiety and panic, and it can make you avoid doing things that you might otherwise enjoy doing. And so there's a lot of push to try and figure out how can we get over these things. I can also mention that we are predisposed to acquire phobias of certain things. Things like snakes and spiders, we are pretty quick to pick up on and dislike right off the bat. So if you see a parent who's afraid of spiders, you're very likely to also be afraid of them as a child. But if you see a parent who handles spiders just fine and doesn't have an issue, then you're probably not going to either. But we have that sort of biological leaning to avoid things that might be harmful. But one of the ways that we can sort of alleviate some of the effects of these phobias is something called systematic desensitization, which you might also see called exposure therapy. And this is a therapeutic technique that's based on the principles of our Pavlovian conditioning. So the idea here is to reduce that fear response, reduce what is actually a conditioned response to something that doesn't actually hurt you. So you have this conditioned response to seeing spiders or snakes or clowns. And so the idea here is that you're exposed to that conditioned stimulus, a picture of one of those, and you have nothing bad happen to you. You don't get bit by the spider or the snake. You don't get approached by the clown. You realize that you're fine. And so eventually, if you're exposed to that stimulus enough without the sort of bad things happening, you should eventually have a reduced conditioned response. So that's the process there. And if you go on into 105, you spend a little bit more time talking about this and similar procedures for treating different kind of psychological disorders. But this one fits in really neatly with our idea of Pavlovian conditioning, just because it uses the exact same concepts. And so that's where I'm going to leave it off for today. We're actually going very, very quickly. I didn't think we'd get through that quick. But I want to start instrumental and operant conditioning on Monday, so I will leave you guys there, and then we will pick up on Monday.